Hello students, in our previous sessions under conic sections we have already discussed about circles and parabolas. Here we shall look into hyperbola. We have studied in our earlier classes that a hyperbola is the particular case of the conic ax square plus 2hxy plus by square plus 2gx plus 2fy plus c is equal to 0 when ABC plus 2FGH minus AF square minus BG square minus CH square is not equal to 0 and H square is greater than AB. The analytical definition of a hyperbola is as follows. A hyperbola is the locus of a point in a plane which moves in the plane in such a way that the ratio of its distance from a fixed point called focus in the same plane to its distance from a fixed line called directrix is always constant, which is always greater than unity. The constant ratio is generally denoted by E and is known as the eccentricity of the hyperbola. If S is the focus, Z Z dash is the directrix and P is any point on the hyperbola, then by definition SP upon PM is equal to E or SP is equal to E multiplied by PM. Let us look into one example. Find the equation of the hyperbola whose focus is 1, 2, directrix the line x plus y plus 1 is equal to 0 and eccentricity 3 upon 2. Let S 1, 2 be the focus and let P x y be a point on the hyperbola. Draw perpendicular PM from P on the directrix x plus y plus 1 is equal to 0, then SP is equal to E into PM by definition. Therefore, using distance formula we can write this as square root of x minus 1 whole square plus y minus 2 whole square is equal to 3 upon 2 into x plus y plus 1 divided by square root of 1 square plus 1 square, which on simplification gives us x minus 1 whole square plus y minus 2 whole square is equal to 9 upon 4 into x plus y plus 1 whole square upon 2. This we have obtained on squaring both the sides. Now, we have 8 multiplied by x minus 1 whole square plus y minus 2 whole square is equal to 9 into x plus y plus 1 whole square, which gives us 8x square plus 8y square minus 16x minus 32y plus 40 is equal to 9x square plus 9y square plus 9 plus 18xy plus 18x plus 18y, which on solving reduces to x square plus y square plus 18xy plus 34x plus 50y minus 31 is equal to 0, which is the required equation of the hyperbola. Now, let us look into the equation of the hyperbola in standard form. This is the equation of the hyperbola in the standard form: x square upon a square minus y square upon b square is equal to 1, where b square is equal to a square multiplied by e square minus 1 within brackets. Now, students, let us look into the concept of tracing of hyperbola. The equation of the hyperbola is x square upon a square minus y square upon b square is equal to 1. Take this as equation 1. Therefore, y is equal to plus or minus b upon a into square root of x square minus a square. Take this as equation 2 and x is equal to plus or minus a upon b square root of y square plus b square. Take this as equation 3. In order to trace the graph of the hyperbola for the first equation, we observe the following points. Symmetry. For every value of x, there are equal and opposite values of y. Similarly, for every value of y, there are equal and opposite value of x. So, the curve is symmetric about both the axes. What is origin here? The curve does not pass through the origin. Intersection with the axis. The curve meets the x axis at y is equal to 0. Putting y is equal to 0 in third equation, we get x is equal to plus or minus a. So, the curve meets x axis at a, that is a comma 0, and a dash, that is minus a comma 0. Putting x is equal to 0 in second equation, we get imaginary values of y. So, the curve does not meet y axis. What about the region? From second equation, we find that for minus a less than x less than a, the value of y are imaginary. So, the curve does not exist between the lines x is equal to minus a and x is equal to a. From second equation, we find that y is equal to 0 at x plus or minus a, and if x increases and is greater than a, the values of y also increase. Similarly, if x decreases and is less than minus a, y also increases. With the help of the above facts and by joining some convenient points on the hyperbola, the general shape of the hyperbola x square upon a square minus y square upon b square is equal to 1. Now, let us discuss about the second focus and the second directrix of the hyperbola. It can be shown that the hyperbola x square upon a square minus y square upon b square is equal to 1, b square is equal to a square into e square minus 1 has second focus minus a e comma 0 and second directrix as x is equal to minus a upon e. Now, let us look into some various elements of hyperbola. For the hyperbola x square upon a square minus y square upon b square is equal to 1, we have following points. Vertices. In the figure, the points a and a dash where the curve meets the line joining the foci s and s dash are called the vertices of the parabola. The coordinates of a and a dash are a comma 0 and minus a comma 0 respectively. Let us see the transverse and the conjugate. In figure, the straight line joining the vertices a and a dash is called the transverse axis of the hyperbola. Its length a dash is generally taken to be 2a. The straight line through the center which is perpendicular to the transverse axis does not meet the hyperbola in real points, but if b comma b dash be the points on this line such that CB is equal to CB dash, that is equal to B, the line BB dash is called the conjugate axis such that BB dash is equal to 2B. Foci. In the figure, the points S, that is AE comma 0 and S dash, that is minus AE comma 0 are the foci of the hyperbola. What about the directrix? In the figure, ZK and Z dash K dash are two directrices of the hyperbola and their equations are x is equal to a upon e and x is equal to minus a upon e respectively. What about the center? In figure, the middle point C of a dash bisects every chord of the hyperbola passing through it and is called the center of the hyperbola. Let us look into the eccentricity. For the hyperbola x square upon a square minus y square upon b square is equal to 1, we have b square is equal to a square into e square minus 1, that can be expressed as e square is equal to a square plus b square upon a square, that can again simplified as 1 plus b square upon a square. So, E is equal to square root of 1 plus b square upon a square, which can be further simplified as square root of 1 plus 2b square upon 2a square. So, E is equal to square root of 1 plus conjugate axis upon transverse axis whole square. Now, students, let us see how to calculate the length of the lattice rectum. In figure, LS L dash is the lattice rectum and LS is called the semi lattice rectum. TS dash T dash is also a lattice rectum. The coordinates of L are AE, SL. As L lies on the hyperbola x square upon a square minus y square upon b square is equal to 1, the coordinates of L will satisfy the equation of the hyperbola. AE whole square upon a square minus SL square upon b square is equal to 1, which can be simplified as SL whole square is equal to b square into e square minus 1, which can be expressed as SL whole square is equal to b square into b square upon a square. Since b square into e square minus 1 can be written as e square minus 1 is equal to b square upon a square. So, SL is equal to b square upon a. Therefore, SL is equal to SL dash, that is equal to b square upon a. Hence, length of the lattice rectum is equal to 2 into SL, that is equal to 2b square upon a, which can be simplified as 2a into e square minus 1. Now, let us see how to calculate the focal distance of a point. The distance of any point on the hyperbola x square upon a square minus y square upon b square is equal to 1 from its foci are known as the focal distances of that point. The difference of the focal distances of any point on a hyperbola is constant and equal to the length of the transverse axis of the hyperbola. On account of this property, a second definition of the hyperbola may be given as follows. A hyperbola is the locus of a point which moves in such a way that the difference of its distances from two fixed points, that is foci, is always constant. Now, let us look into what is conjugate hyperbola. A hyperbola whose transverse and conjugate axis are respectively the conjugate and transverse axis of a given hyperbola is called the conjugate hyperbola of the given hyperbola. The conjugate hyperbola of the hyperbola x square upon a square minus y square upon b square is equal to 1 is minus x square upon a square plus y square upon b square is equal to 1. Its shape is shown in the figure. The eccentricity of the conjugate hyperbola is given by a square is equal to b square into e square minus 1 and the length of the lattice rectum is 2a square upon b. We can see in the figure here y and y dash axis with x dash, o and x. We have got the various results related to the hyperbola x square upon a square minus y square upon b square is equal to 1 and its conjugate minus x square upon a square plus y square upon b square is equal to 1 are given in the following table for ready reference. We have here a table showing hyperbola and conjugate hyperbola. The equation for hyperbola is x square upon a square minus y square upon b square is equal to 1, and whereas for conjugate hyperbola we have minus of x square upon a square plus y square upon b square is equal to 1. Let us look into the coordinates of the center. It is origin in both the cases for hyperbola and conjugate hyperbola, that is 0, 0. What about the coordinates of the vertices for hyperbola? They are a0 and minus a, 0. In the case of conjugate hyperbola, the coordinates of the vertices will be 0, b and 0, minus b. What about the coordinates of foci for hyperbola? They are plus or minus ae, 0 and 0, plus or minus be for conjugate hyperbola. What about the length of the transverse axis for hyperbola and conjugate hyperbola respectively? They will be 2a and 2b. The length of the conjugate axis for hyperbola will be 2b and 2a in case of conjugate hyperbola. Now, what are the equations of the directrix for hyperbola? They will be x is equal to plus or minus a upon e, and for conjugate hyperbola y is equal to plus or minus b upon e. What about the eccentricity for hyperbola? It is e is equal to a square plus b square upon a square, and in case of conjugate hyperbola e will be b square plus a square upon b square. The length of the lattice rectum for hyperbola will be 2b square upon a, and it is going to be 2a square upon b for conjugate hyperbola. In case of equation of transverse axis for hyperbola y is equal to 0, and for conjugate hyperbola it is going to be x is equal to 0. Equation of the conjugate axis for hyperbola will be x is equal to 0, and for conjugate hyperbola it is y is equal to 0. What about the focal distances? In case of hyperbola, the focal distance will be Ex plus or minus a, and for conjugate hyperbola it will be Ey plus or minus b. The difference of the focal distances of a point in case of hyperbola will be 2a, and the distance of focal distances of a point for conjugate hyperbola will be 2 into b. If the center of the hyperbola is at the point h, k and the directions of the axis are parallel to the coordinate axis, then its equation is x minus h whole square upon a square minus y minus k whole square upon b square is equal to 1. So, students, today we discussed about hyperbola and the definitions related to it. In the coming sessions, we shall solve some examples involving hyperbola. Thank you.